every daggone time. You think by now I would check it. All right, so on page 5 of your new packet that you grabbed yesterday. And remember, in reality, this is kind of like the first part of your packet. You'll get all the solving stuff on Monday. All right. Okay. So we're doing square root arithmetic today, which is just a fancy name for saying square root operations. So how to add them, subtract them, multiply them, and divide them. Now, we already talked about multiplying yesterday. What's the biggest takeaway from multiplying square roots? What's the biggest takeaway? Lucas.
Is it like you can add the square roots together? So like square root of 8 and square root of 5, you can just do the square root of 8 times 5?
Right. So in other words, if you have two square roots being multiplied together, you can combine it all into one square root and just multiply the two numbers underneath those radicals. So that's kind of what it's describing here. So if you start with 2, you can turn it into 1, and you can undo it. So if you start with 1, you can turn it into 2. That's how simplification works, essentially. All right, so let's do a couple of these. So square root of 8 times 5, square root of 5, what will that give us? The square root of what? 40, because it gets a square root of 8 times 5. Now, simplification-wise, if I broke 40 down to its factors, which one's going to have a nice perfect square for us? 4 and 10. All right, so if I rewrite 40 as 4 times 10, what can I take out? The square root of 4, which is just 2. So this will be 2 square root 10. Now, does 10 have any perfect square factors in it? Nope. So we're done. All right. Square root of 6 times the square root of 15. What would that give me? Square root of what? 90. Good. So you just multiply 6 times 15, put it under a radical. Now, if we simplify, how can I break it up 90? 9 and 10. So this would be the square root of 9 times 10. So what will my answer be simplified? 3 square root 10. And we know that 10 can't break down further into a perfect square, so we're done. All right, now, this last one. Here's a little trick. All right. If you're multiplying the same radical with the same number underneath, the radicals essentially cancel each other out, and you're left with whatever is under the radical. So, in other words, how could I rewrite this besides square root of 100? The square root of 10 squared. Yep. So I can rewrite this as a square root of 10 squared. Or we could write it as the square root of 100, whatever floats your boat. But with the square root of 10 squared, what's going to happen with the square root of 10 squared? It goes bye-bye. So what are we left with? 10. All right. So this only works if you have the exact same number under the square root. All right. You can essentially just keep the number that's under both of them and take away the square root because you're essentially squaring them. Or you can just keep doing the multiplication and then take the square root of 100, which is in fact 10. Just a little cool thing that happens there. All right. Any questions on multiplication part? All right. So they're doing the same thing down here. So without actually doing the multiplication property, what's the answer to A? 5. Square root of 5 times the square root of 5, square root of 25, which is 5. What about B? C? D? Good. Now, why are we talking about this? Well, that's where rationalizing a denominator comes in. So, when we're dividing rationals, we simplify it. We do not like to have a square root in the denominator. All right? It's just something that we just don't like. You don't want an irrational number in your denominator. You want it to be like a nice, friendly, rational number. So, what you do to handle that is we do something called rationalizing the denominator. And essentially, all that means is we're removing the square root from the denominator. All right. So let's look at exercise 3. So we're going to consider this fraction 2 over the square root of 3. First off, I want you guys to put that in your calculator and tell me what you get. So in your calculator, everyone should have a calculator. That's why I told you you might want to grab one. Put it in your calculator. Tell me what you get. And I want every decimal place that you see on that calculator. So everyone should be putting it in. So again, guys, don't wait for me to write it. I want everyone to put it in. All right, so let's go with, not here, Reynolds. What decimal did you get when you put it in your calculator? Okay, 1.154. Good. So, Reynolds, is that rational or irrational? Yep, clearly irrational because we don't have a terminating decimal. We don't have a nice pattern of a decimal. It's just a bunch of random numbers that it looks like. Now, we're then going to multiply that fraction by its denominator. So the denominator over its denominator. All right. Now, technically, if I'm multiplying by the square root of 3 over square root of 3, what am I technically multiplying by? 1. So remember, with fractions, you can multiply anything you want to it as long as it's the same thing over itself. All right, because you're essentially just saying, okay, I'm just changing up the fraction a little bit, but it's still going to give me the exact same fraction. All right, so if I do that, what is 2 times the square root of 3? Let's go with Shelby. So 2 times the square root of 3. Not quite. So Shelby, think about it this way. If we're just multiplying dead across, all right, could I multiply the 2 to the 3 under the radical technically? No. So how would I write it if I couldn't multiply to it directly? Right. 2 square root of 3. So again, guys, if you do not have a radical over both your numbers, you can't multiply them together. You just have to write it as like a simplified radical. Now, we all know that the square root of 3 over the square root of 3 is what? Not over 3, sorry. Square root of 3 times the square root of 3. What would that be? 3. So this is technically our rationalized fraction. Now take a minute and put that in your calculator. All right. I want to see if you get the exact same thing that we got previously. So thumbs up if you got the exact same thing. Right. That's what you should have gotten. So this is the same as what we got when we did 2 over the square root of 3. Now again, why do you think that's true? So why is this fraction equivalent to the original one? I kind of already said it. Why is it true? What do we technically multiply to our 2 square root 3? We technically multiplied what? We technically multiplied 1 to it. All right. So technically speaking, square root of 3 over the square root of 3 is equal to 1. So we created an equivalent fraction. And that's the same logic as if, and you don't have to write this down, but that's the same logic as if you did 1/2 times 2 over 2 and you got 2/4. All right. We all know 2/4 is 1/2. Okay. It's the same logic. So again, what we just did right here is what we call rationalizing the denominator. Meaning we got the radical out of the denominator. So let's try a couple of these, and we need to make sure that they're all in simplest form. So let's do letter C. So letter C. What would I multiply both the numerator and the denominator by? The square root of 10 over the square root of 10. So what do I get? 5 square root of 10 over, we're multiplying a rational by its the same rational, so this will just be 10. And we know that the square root of 10, you can't simplify it down any further. All right. Now look at letter E. So first off, what am I multiplying the top and the bottom by? The square root of 8. So this would be negative 24 square root of 8 all over 8. Now, we got a little issue here. What's true about the square root of 8? I can simplify it further. What can I simplify the square root of 8 down to? 4 square root 2. So this is now negative 24 times 4 over the square root of 2 all over 8. And what's negative 24 times 4? Negative 96. This is negative 96 square root of 2 over 8. Now, do you think I'm done simplifying here? What do you guys think? No, why not? Right. So, guys, if there are two numbers being multiplied and divided, all right, we can technically separate them to simplify. So technically speaking, since the 96 is outside the radical, we can divide the 96 by that 8. Now, we cannot touch the 2. The 2 stays. All right, you can never divide by a radical by a whole number, like into a whole number. So if, say you had like the square root of 40 under there, all over 8, you would not get the square root of 5. That's not how it works. So what's negative 96 divided by 8? Negative 12. So this is equal to negative 12 square root of 2. Now, if you weren't 100% that you did that correctly, what's a good way you could check yourself? Yeah, hold on.
Amber number C, we got different answers. Like every single one.
Oh, wait. I screwed that up. So the 2 goes here. So this would be 48. So this would be 6. I wrote the wrong thing.
Amber C, we got something different.
What'd you get for? Oh, yep. This one, not fully simplified. You got to simplify this fraction. So this is the square root of 10 over 2. So more of the story, you guys, is simplify the fractions. So over here, I took out the 4 because 4 times 2 is 8, but I still wrote it as 4. I should have wrote it as 2 because the square root of 4 is 2. But you know what, guys? The process still is the same. So even though I use the wrong numbers, the process still is the same. All right. All right, let's try one more. Try letter H on your own. Make sure it's fully simplified. Now, if you have NumWorks calculators, I only want you to use it to check your answer. All right, thumbs up if you're ready. Give you guys one more minute. All right, thumbs up if you're ready. All right, so let's go with Eli. What'd you get for H?
I got negative 3 square root of 12. Simplified.
Okay. So you're halfway there. All right. So he got negative 3 square root 12 over 12. So the last part you had to do was simplify. So Blake, help him out. All right. Does anyone? All right. So here's what I got. So if we're looking here, all right, I multiplied by the square root of 12 over the square root of 12 first. I got what equal I got. Negative square root of 12. Negative 3 times the square root of 12 over 12. Now, from there's two ways you can go about this. You can either simplify this fraction first and then simplify the square root of 12, or you can simplify the radical first and then simplify the fraction. You can do it either or. You can do the same thing. I did the simplifying the radical first. So 12 can be broken down to 4 times 3. And if you take the square root of 4 out, that gives you the 2 square root of 3, which I would multiply to the negative 3. So I would get negative 6 square root of 3 over 12. You can then simplify the negative 6 over 12. And that'll give you negative square root of 3 over 2. Any questions on that? Do we need to do another one? Okay, we're going to do another one. All right, let's do letter G. All right, so walk me through my steps. So let's go with Elizabeth. Not here. Not Elizabeth A, Elizabeth P. All right, so Lucas, what would be my first step here? Right, we multiply by the square root of 5 over the square root of 5. And what would that give me, Lucas? Mm-hmm. Good. All right. Now, let's go with Danny. So, Danny, could I simplify the square root of 5? No. But is there somewhere else I can simplify? Right. We could simplify the 20 over 5. So how would that simplify, Danny?
It'd be 4
Mm-hmm.
square root of 5 over 1.
4 square root of 5 over 1. Which, Danny, how can I write that in a separate way?
4
Good. And that would be your answer. So always check the whole numbers outside of the radical and see if they can simplify. All right. Try letter F on your own. Take a minute, try letter F on your own. All right, thumbs up if you're ready. You guys another minute. Now, guys, while you're still working, just listen. Knowing how to rationalize the denominator, that's a good skill to have. But the biggest takeaway that will really help you when we get to solving quadratics, especially with quadratic formula, is simplifying those numbers outside of the radical. So simplifying the radicals and then simplifying those fractions outside of them. Those will really, really help you when we get to quadratic formula. All right, thumbs up if you're ready. All right, so let's go with Tyson. What's my first step here?
First, you multiply it by the square root of -6. Like,
Just the square root of 6, not -6. Yeah, you're good.
you get 15 square root of 6 over 6.
All right, now I'm going to stop you there. All right, what is my next step, Lizzie? Okay, so let's talk it through together then. So first, let's look at the square root of 6. Can I break that down to any factors that are perfect squares? So, like, is there any numbers that multiply by 6 that can give you a perfect square? So, guys, if I break down 6, Lizzie, what's 2 factors of 6? Besides 1 in itself. 3 and 2. Are either of those perfect squares? No. So, square root of 6, we can't break it down any further. All right. But what about the fraction outside the square root, Lizzie? So 15 over 6. Could I simplify that anyway? So think about like a fraction, 15 over 6. Do they have something in common that I could take out or divide out? What? 3. So if I divide the top and the bottom by 3 over 3, what do I get? 5 over 2. So this would be 5 square root 6 over 2. And that would be your answer. So guys, that's also a way you can think about it. If you can't see the fraction, like when it's next to the radical, take it out. Do it by itself, and then just rewrite it, but slap the radical next to the number on the numerator. All right? Any questions on rationalizing denominators? Make a little bit more sense now. Do I need to do another example? All right, so moving on. Okay, last thing we're going to talk about, adding and subtracting radicals. Pretty similar to combining like terms. All right, that's the way I think about it. It's very, very, very similar to combining like terms. So when you add and subtract expressions involving square roots, let's just simplify these expressions. All right. So first off, letter A, what's 3x plus 5x? 8x. 8y minus 2y. 6y. And then 9t plus 2t minus 6t. 5t. So 19 plus 2t is 11t. Minus 6t is 5t. So what was I essentially doing here? For the first three, what was I doing? I was combining like terms. How did I know they were like terms? So how did I know that 3x and 5x were like terms? What told me they were like terms? They had the same variable, same exponent connected to that variable. Well, guess what? Radicals are almost like combining like terms. But instead of having the same variable, you need to have the same radical. Meaning you have to have the same number underneath the radical, and then you can just add the coefficients or the number outside of the radical. So for letter D, notice how we both have square root of 2 here. All right. So all I would have to do here is my final answer is going to contain a square root of 2. That's just a definite. Just like how up here our final answer contained that x. But Now we can just add the 3 and the 5 on the outside. So that would be what? 8 square root 2. Now let's check ourselves. So in the calculator, I'm going to type in 3 times the square root of 2 plus, plus 5 times the square root of 2. And now I'm going to type in 8 square root of 2. We get the exact same thing. So it does work. So treat adding and subtracting radicals like combining like terms. All right. You have to have the same number under the radical, and it has to be the same type of radical. Now, remember, in this class, we mainly just deal with square roots, but say one of them was a cube root, you can combine them then. All right, because it's not the same type of root. So if I look at letter E, what do you think my answer will be? 6 times the square root of 5. So we know the square root of 5 is kind of our like term, and then we just subtract the two numbers. What about the last one? It'll be 5 square root of 3. So square root of 3 is kind of our common part, and then we add the 9 and the 2, subtract the 6. Any questions on that? Now, the great thing about radicals is even though it's very similar to combining like terms, we know that when we combine like terms with polynomials, so they have the x's, the y's, the t's, the x squareds, whatever, we know that we can't change the variable to look like something else. That cannot be the same. The same cannot be said about radicals because we know we can simplify radicals. So in other words, sometimes, say if we look at letter A, we can simplify a radical to make it so that we have the same number under the radical and then we can add them together. So for letter A, which radical do you think I could simplify? The square root of 8. So let's simplify the square root of 8. So 2 factors of 8. 4 and 2. So I get the square root of 4 times 2, which will give me what? So I take the square root of 4 times the square root of 2, which is what? So guys, we're just simplifying. I don't want square root of 8. I'm trying to get down. 2 square root 2. So this will be 2 square root 2 plus 5 square root 2. Now I have the same number under the radical. So I can now combine them. So if I do 2 square root 2 plus 5 square root 2, what would I get? 7 square root 2, because 2 plus 5 is 7. That's all we have to do. Ladies, shh. So let's look at letter B. Which radical do you think I could simplify? 27. Now, let's take a guess. What number do you think will be left under the radical when I simplify? 3. Because we have another square root of 3. So we're going to shoot for a square root of 3. All right. So we're going to leave the 2 alone for right now on the outside, but we're just going to simplify the square root of 27. So what are 2 factors of 27 besides 1 in itself? 9 and 3. All right. So I can rewrite this as the square root of 9 times the square root of 3. So what does this simplify down to? 3 square root 3. So I now have 2 times 3 square root 3 minus the square root of 3. So remember, you got to multiply that 2 and the 3 first before you do the adding and subtracting because PEMDAS. All right, so this will be 6 square root 3 minus the square root of 3. Now, if we don't have a number in front of that square root of 3, what is the unspoken number that's being multiplied to it? 1. So this is the same thing as doing 6 minus 1, which would be what? 5 square root 3. All right. Any questions? Heads up, guys. Come on. Try that last one on your own. So you have to simplify 2 radicals. So try that last one on your own. So simplify the radicals first if you can. Then add and subtract the numbers in front of the radicals. All right, thumbs up if you're ready. One more minute. All right, thumbs up if you're ready now. All right. So let's go with Caitlin. So Caitlin, what are the 2 radicals I'm going to have to simplify? Good. So Caitlin, help me simplify the square root of 20. So what are 2 factors that multiply to 20? 5 and 4. So I can rewrite this as square root of 4 times the square root of 5. So what would I get? Good. Now I'm going to bring down the 9 square root of 5. So now let's go with Reagan. So walk me through simplifying the square root of 45. All right. So what are some factors of 45? All right. There's nothing wrong with that. So this would be the square root of 9 times the square root of 5. So what's the square root of 9, Reagan? 3. So this would be 3 times the square root of 5 And since we have a negative 1 on the outside, it's like we're multiplying negative 1 to 3, so this would be negative. Now, what would my last step be, Nathan? So it's my last step. So I've simplified all my radicals, so what's next? Right, so we combine our like terms because we now have a square root of 5 directly across. So 2 plus 9 is 11, minus 3 is 8. This would be 8 square root of 5. Any questions on anything related to radical operations? All right, so your assignment, there is a new Delta Math for you. All right. It covers all of the different operations that we talked about. And don't forget, the one from yesterday is due tonight by midnight. So if you didn't finish it, make sure you get that one done as well.